Good morning, class. Sorry for the delay. We were busy with number patterns. It was chapter 3. You guys had some homework. It was exercise 3.1. Number? First column. Any issues with number 1 in the first column? Any issues? No? Number 2? You had them to do. No? But I want you guys to add number 2 to your homework. Now, for Monday. Number 3, you had to do, no? Any issues here? Number 4, you had to do, no? You had to do. Okay. Any issues number 4? No? Did you guys do the work?
Yes, sir.
Okay. Number 5, you had to do. You had to, okay. Any issue number 5? Number 6, you had to do the first column. Any issues here? No? Number 7, first column? Yes. Any issues here? Okay, and no. Okay. Anything else? No. Right. Let's look at K. This is exercise 3.1. It's on page 59. Exercise 3.1 on page 59. Number 7. Okay. So if you look at K, you got Tn is equal to 5, whilst Tn plus 1 is equal to 2n minus 2. For n is greater than or equal to 1. So in other words, you're going to start where n is 1. Okay. So if n is 1, okay, there's actually a mistake here. You're supposed to be T1. Does it make a difference to your understanding now? So will you be able to do it now? Huh? Yes, okay. So what I'm going to do is I'm going to give you 2 minutes just to sort this out quickly, okay? So T1 is 5 in the first case and T1 is 1. So I'm going to do it, but just let me I'll give you a chance to attempt it first, okay? Pause the video at this point. Alright, so T1 is equal to 5, Tn plus 1 is equal to Tn minus 2, for n is greater than. So now we start by saying if n is 1. Okay, if n is 1, then we have T1 plus 1 is 2 is equal to T1 minus 2. Okay, do you guys understand? Okay, so wherever n is up to the 1. So what is the value of T1? 5. So 5 minus 2 is 3. So T2 is 3. Can you see that? What does the next one be? It would be for n is equal to 2. So it's going to be T2 plus 1 is 3 is equal to T2 minus 2. So what is T2? 3. The 3 minus 2 is negative 1. Can you see that, people? Next, T. This is now where n is equal to 3. But this would be 3 plus 1, which is 4. It's equal to T3 minus 2. T3 is negative 1, minus 2 is negative. So therefore, what's my sequence? Your first term is 5. Where do I get that from? From here. Your term 2 is 3. Term 3 is negative 1. Term 4, negative. Term 3. This one? This 1. Okay, so I made a mistake there, so that's 1. So this must be minus 1. Is that correct? So my pattern is actually 1, then 1. Sorry about that. Okay. So you guys understand? Go straight into the next one, or you need a minute for the next one? Alright, we'll go straight. L. So we start with n is equal to 1. If n is equal to 1, what do we know? This was 1, eh? Then it's going to be 1 plus 1, which is T2 is equal to 3 times term 1. Not so? So it's going to be 3 times 1, which is 3. So that is T2. So when n is equal to 2, so I put 2 in here now. So 2 plus 1 is 3 is equal to 3 times T. So it's 3 times 3. And 3 times 3 is 9. So n is equal to 3. This is for term 4, which is 3 times T3. Not so? So it's 3 times 9, which is 27. So there is T1 is 1. T2, 3. T3 is 9. T4 is 27. Alright, you guys understand? Any confusion there? No? Patterns with a linear general term. That's your next heading. Patterns with a linear general term. Yes? Yes? Didn't you write? You finished? No, you don't need to. I just need you to write patterns with a linear general term. I'm reading from which page is this one? Example on page 61. When a general term is Tn is equal to Pn plus Q. Remember I gave you a formula the other day in the previous lesson. Eh? What was that formula? Tn is equal to A plus N minus 1T. Not so? Right. That's a formula we will be using. Not Pn plus Q. The difference between the consecutive terms is P. To us it's going to be D. Previously we might have given the general term of the sequence in that form. This is what we call recursive formula method. Okay, this is a recursive formula method. But it's not useful when trying to find the 100th term. Because imagine you must find the 100th term. So what do we need? We need term 99 and term 98 and then term 97, then term 96 and so on. Can you see that? So like if you go up here to this recursive formula that we had here, imagine you had to work out the 100th term. You must go all the way to 100. However, this formula here that we are using, which is Pn plus Q or Tn is equal to A plus N minus 1T, that formula, you can just substitute the 100th term in some easy, or the 100 to work out the 100th term. Okay. But it's not useful to try and find the 100th term. Say once you have worked out all the 99 preceding terms, you get the 100th term in the sequence. We can write the general term in. Here we go. This is example on page 61. The difference between consecutive terms is 4 and the first term is 2. Find the general term. That is simple. No? It said it has a difference between consecutive terms. What does consecutive terms mean? One after the other. Not so. Is 4. So what is going to be that 4 value? What does that 4 represent? In the formula Tn is equal to a plus n minus 1d. It's the difference. So what did I say? How do you calculate d? Is t3 minus t2 is equal to t2 minus t1. Did I tell you that? Yes. So the difference, that the minus between consecutive terms is terms that follow each other. Okay? So that is your d. There's 4d. Your d value is 4. And the first term is 2. What is your first term value? 8. So you just do the substitution and you simplify it from there. Assalamualaikum. How are you? Okay, so the difference between consecutive terms is 4, so your d value is 4, and it has a first term of 2. So Tn is equal to 2 plus n minus 1 times 4. So it's 2 plus 4n minus 4. So it's going to be 4n minus 2. All agree with that?
Yes, sir.
Okay. Oops, not grade 11 yet. And you're saying you must first get through grade 10. Yes. Right, there we go, exercise 3.2. Okay? You can do the whole exercise with me for homework. Okay? It's fairly simple, no? Why are you looking around? What's wrong with your nose? So what's wrong with your nose? Okay, relax. Now why must you not stand in front of the whole class now and show? Okay, next reading, arithmetic sequence. Arithmetic sequence. But you guys have done this number patterns in grade 8 and 9, eh? Or grade 9 basically. Huh? No. Okay. But you guys understand what I'm talking about so far? Okay. The next subheading, arithmetic sequences. Okay, this example on page 63. Okay, arithmetic sequences, we are reading on page 63. So here we are told that if a sequence has a constant where sequence has a constant or a common difference between any two successive terms, successive or consecutive is the same, or yeah, it's the same thing, terms, the general term is Tn is equal to Pn plus Q. The sequence is called an arithmetic sequence. Okay, so you can write that first sentence down. Okay, the common difference is denoted by D, and D is equal to T1 plus T2 minus D is equal to Tn plus 1 minus Tn. So in other words, this is going to be T2 minus T1. Or it could be T8 minus T7. Or it could be T100 and minus T99. It could be T1078, 1077. 1 and its prior number. Okay, the previous one. D is equal to any term minus its predecessor, the preceding term. Okay. Predecessor is the one that comes, who came before. No? If we let the first term of arithmetic sequence be A, then the second term is going to be A plus D. Why? So I'm just adding my common difference every time. Yes, Michael? You're not done? You're not? Just write the page number down here. Carry on. Next page 60. Okay, so to work out the next term, we just add a D all the time, not so. So the first term is A, the next term is going to be A plus D, then the next term is going to be A plus 2D. Okay? Then it's going to be A plus 3D and so on. So to move from one term to the next, you're adding a D all the time. You guys understand? So then for term 9 is going to be A plus 8D. Can you see it's a 9? Oops, sorry. You see it's 9, and we got the 8. We got the 4, and then we got the 3. With the 3, then we got the 2. So what do you notice? It's always 1 less than the term number. Not so. And the term number is denoted with an N. Not so. So in other words, Tn is equal to A plus the 1 prior to that, so it's N minus 1 or 1 less than. And that's the formula I gave you in the first lesson already. Okay? So they derive the formula. Tn is equal to A plus N minus 1t. Okay. The general term of arithmetic sequence is, alright, we spoke about that there. First example. Show that the sequence is arithmetic. So when you would something be arithmetic is when it has a common difference. So write that down. To prove that the sequence is arithmetic, we prove that it has a common or constant difference. Okay, so people, that is term 1. Can you see that? Your term 1 is 1, your term 2 is 2 and a quarter, and term 3 is 3 and a half. So what you do is you say, okay, what is term 2 minus term 1? So it's going to be 2 and a quarter minus 1. What is 2 and a quarter minus 1? Check. Sorry? 1 and a quarter. Okay, sound like mathematicians now. So now T3 minus T2. So it's going to be 3 and a half minus 2 and a quarter. Work that out. So what do you get? 5 over 4. No? Which is 1 and a quarter. Not so? So what do you notice? That since T3 minus T2 is equal to T2 minus T1, which is your D value, not so? Which is 1 and a quarter. Therefore, the sequence is an arithmetic sequence. You guys understand? What if that was term 3 minus term 2 was not equal to term 2 minus term 1? It's not an arithmetic sequence. You guys understand? Let's look at the next example, example 2. So it's on page 63. It says determine the general term of the sequence. So you got 4, 7, 10. What does the dots mean? Continues following that pattern. What is my A value here? 4. Does it have a constant difference? Yes. How do I move from one term to the next? You're adding 3. Then I add 3 again. Not so. So that's my D value. Not so. So plug it into the formula and simplify. Okay. So what do we have? Tn is equal to a plus n minus 1d. Not so. What's your a value? 4 plus n minus 1 times 3. Multiply that in, I'll get 4 plus 3n minus 3. So it's 4n plus. Okay, you all okay with that? Right. 3n plus 1. What's wrong with me? So many things, no? Many things. Right, you guys understand? Example 3. And this is on page 64. Example 3 on page 64. Okay. Alright. Determine which term of the sequence 25, 14, 3 is equal to negative 52. Okay. So in other words, if we got 25, 14, 3, and if that pattern carries on, there will be a term that's equal to negative 52. You guys understand? They want to know which term in that sequence will be negative. Okay, so what we do first is, we work out the general term. Okay, remember this is the nth term, né? The general term is a plus n minus 1d. I'm sure you can all work out the general term there at this point. Not so? Right, work out the general term quickly. Okay, so what's my a value? 25 plus n minus 1 times. How do I move from 1 to the next? You're subtracting 11, not so? So it's negative 11. So I get rid of the brackets there. So it's 25 minus 11n. Negative 1 times negative 11 is plus 11, not so? So it's negative 11n plus 36. Not so? So what is Tn? Tn is the nth term. Remember, if I put n in, so say you want to work out the 100th term, then I put 100 where I see n. Can you see that? So here in this case, I'm actually calculating the value of n. You guys understand? So you work in the reverse. So the nth term is negative 52. So I say negative 52 is equal to negative 11 plus 36. So what is this now to us? An equation, not some linear equation. So now you guys can solve the linear equation. Now then, assessment. So now they were yeah, just like you said. Now send them a message again now to ask who's interested in responding. Nobody responded. So you can just wait and see. But I've seen them as often. Format extra class. Yeah? You feel this is really fun. Oh, I know. These are forms. How come you put it in front? You can put it. But this is the first year that we actually invited to this. Is it? I didn't see this one. That one. Alright, so what do we get? We take it over. Becomes negative 52 minus 36 is equal to negative 11n. Negative 11n is equal to negative 88. Therefore n is equal to 8. Not so. That means to say the 8th term is negative 50. Which means to say when I extend this to the 8th term, you will see the 8th term will be negative 50. You guys understand? Right. Sorry? Okay, yeah, you want more. Right, exercise 3.3. Out of exercise 3.3, you do for me number 1, the first column. Number 2, the first column. Number 1, the first column. Number 2, the first column. Number 3, 5. Then you do 3 and 5. Right. People, enjoy your weekend and the rest of the day. Good afternoon, class. Oh, it's still morning, sorry. Morning. Half one.